When we are asked to find the interval of convergence, the first thing we need to do is to use the ratio test in order to determine the interval without the endpoints. So if we apply ratio test to this power series, we would get 2 to the power of k plus 1 over 2 to the k times ln k plus 2 over ln k plus 3 times x to the k plus 1 and x to k. So then, this is as limit of k is approaching to infinity. So if you take the interval of this, which it is between 1 and negative 1, then you would get 2x smaller than 1, which means that x is between 1 and 2 and negative 1 and 2. Do not forget the absolute value, otherwise your answer would be incorrect. Now we need to check the endpoints, and we need to use the convergence tests we learned before for that. So if you look at x equals 1 over 2, we put 1 over 2 for x, and we get 1 over ln k plus 2. So this one diverges if you use the method of direct comparison. ln k plus 2 is always smaller than k. So 1 over ln k plus 2 will be bigger than 1 over k. Since 1 over k diverges, then, and it's a p series, and p equals to 1, then the series that we are asked to determine its convergence diverges by direct comparison. Now, we need to now find the other endpoint at x equals to negative 1 over 2. This time we get the alternating series negative 1 to the power k over ln k plus 2. Now, for this part, we will use the alternating series test, in which we are going to first look at if there is a positive series excluding denominator, the alternating series part of this equation. Then we check for the nth term test and put little check marks next to them, and then we check if the next term is smaller than the previous, and in this case it is. So then we can confirm that this alternating series converges. So we are going to exclude the endpoint 1 over 2, but we are going to include the endpoint negative 1 over 2, and our interval will be this. At x equals to 2, the approximation of this function, the Taylor approximation of this function, would look like this. Over 1 factorial plus f second derivative over 2 factorial times again x minus 2 squared. And then it goes on like this. So if you put in the variables the numbers that we are given to write our 4th degree approximation, then we would get f2 is equal to 6, f derivative 2 is equal to again 6 times x minus 2, plus the second derivative is equal to 12. So if we divide it by 2, then we would get again a 6. Then our third derivative is equal to 8. If we divided this by 3 factorial, then we would get 4 over 3. Then the last thing is, if we divide 24 by 4 factorial, then we would get only 1 for that term. And this is the fourth degree Taylor approximation of fx in this case. The question is asking us the Taylor approximation of x over 1 minus x squared. So in this case, our idea is that we can make anything geometric. So we are going to try to find what is this a derivative or an integral of a geometric function. Now if we look at it, this is equal to x times 1 over 1 minus x squared. And then if you think about it, 1 over 1 minus x squared is equal to is the derivative of 1 over 1 minus x. So then this is a geometric function with r equals to x and t1 equals to 1. So then if you write the Taylor approximation for this one, we would get 1 plus x squared plus x cubed, and then it goes on like this. Then we need to take the derivative of this to find what this part Taylor approximation is. Now if we take the derivative, we would get 1 plus 2x plus 3x squared plus 4x cubed, and then it goes on like this. Then if you multiply all the terms by x, we will find the Taylor approximation of our original series, which is now in this case x plus 2x squared plus 3x cubed plus 4x to the power 4, and then it goes on, which is equal to n from 1 to infinity n times x to the power n.